Okay, so now that we've done the empirical formulas and been able to determine what those might be, the simplest whole number ratio, then it's important to know what the molecular formula is. The molecular formula, of course, is the formula of something. So, for example, the molecular, and let me just read this, the molecular formula is the formula of substances. It might not be the simplest whole number ratio. So, for example, this right here, CH2O, may or may not be the molecular formula. If it's considered the molecular formula, it would also be the same empirical formula. But we also could notice that this could have 3 different molecular formulas. Obviously, this is glucose right here. Okay, glucose C6H12O6. But notice that its empirical formula is the same. This is a different molecular formula, C5H10O5, but its empirical formula is the same. And notice that this right here, C3H6O3, also is a different molecular formula. All these are different molecular formulas, but their empirical formulas are the same. So they have the same empirical formulas. So in order to determine the molecular formula, hopefully you see that really all we need to be able to do is determine what this factor is. They all have the same empirical formula, but the only difference is the factor you multiply. I did a whole bunch of abbreviations here. I was kind of in the mode here when I was typing this out. But all 3 of them have the same empirical formula, but the only difference is the factor. So notice here we multiplied the empirical formula by 3. Here we multiplied it by 5. Here we multiplied it by 6. And what I'm saying multiplied by, I'm just basically saying whatever the factor that we determined, we just took that and multiplied it by the subscripts of the empirical formula, and we got our molecular formula, okay? So that's the key for that. Now, how do you get that factor and thus the molecular formula? Again, I apologize for the lasers, but you're in luck. The next slide is going to tell you how we determine that molecular formula. Okay? So let's take a look at that. Now, solving for molecular formula. First of all, you'd need to be given the molar or molecular mass. And again, this could be interchangeably. We could have the molar mass of the compound would be given. Okay, so in this case, it's given as 500 grams per mole. Okay. A lot of times, you would need to solve for the empirical formula. Okay. So in this case, again, if I give you only the molecular mass and the percent composition of each, so I say I want to know what the molecular formula is of something, or we want to know what the molecular formula, if you have 50% copper, 30% nitrogen, 20% chlorine, and the molecular mass is 500 grams. Well, because converting and solving for molecular formula, you need that empirical formula so that you also have a factor to multiply it by, you need to solve for the empirical formula. So again, convert your percentages equal to grams. That's that first step. Then change those grams to moles, which is what I've done here. And then divide all the moles by the smallest. Notice that here were my 3 different moles for my copper, nitrogen, and chlorine. I divided it by the smallest, which gave me 1, 3.8, and 1.4. I'm going to round that to 1, 4, and 1. And so these end up giving me my my empirical formula. To determine the molecular formula, you need to solve for that factor. So what factor am I going to multiply that empirical formula by? If this would be 2, then I could simply get Cu2 and 8Cl2. If the factor ends up being 6, then I could get Cu6 and 24Cl6. Okay? But what I'm looking for here is that factor. So, to do that, you take the you take the molecular mass, which is given. This is given, okay? And you divide it by the empirical formula mass. Well, what's the empirical formula mass? You take a look at the empirical formula, determine its mass. So copper has 63.5. There's only one of them. I'm going to add that to, well, nitrogen is 14, but I have 4 of them. So that's what, 56. And then chlorine is 35.5. So I'm going to add those 3 up, and that becomes my empirical formula mass. I'm going to take that 500, which is given, divide it by my empirical formula mass, and round it, and that becomes my factor. So I think I have that right here. 500 divided by 155. When I've added all of this up, I get the 155. I divide and I get 3.2. I'm going to round that to 3. And there's my molecular formula. So that 3 becomes the factor that I use to multiply to get my molecular formula. So my empirical was 1 to 4 to 1. Multiply that by 3, I get 3 to 12 to 3. So my molecular formula in this case would be Cu3N12Cl3. And again, I just made this one up. Whether or not it's an actual molecular formula, I'm not concerned with. I just want you to recognize that that's how you do solve for the molecular formula. Okay? We'll do an extra couple practices here in the next slides.